handout එකත් එක්කම ඔයගොල්ලොත් එක්ක කරන්න. ඒතකොට ලේසි මේක එහෙම share කරන්න. Level expansion. Then, if you consider about the solids, if you given some heats, right? This you have a solid body, the object. You are given some heat to this body. So this body, I told you that in the first day that heat is not the energy stored in a object, right? Stored in an object. It is a energy in transit, right? Transit. So if you given a heat, that heat will not absorb by this body. This heat, normally we call that is heat is absorbed like that, but the actual thing is the body is made with the atoms, right? They have molecules or atoms like this. Then this energy converted to the kinetic energy of those particles. Their vibration speeds being larger. So the larger the vibration speeds, they need more space to vibrate them. So that's at a particular temperature, let's say they vibrate. The amplitude of their vibration is this much. They vibrate like this. Think about this. If some heat is given, the vibration speed is also getting large. So then the vibrational amplitudes of their vibration will be large there. Kinetic energy also getting larger. So then their vibration, that amplitudes will be large. So they need more space to vibrate them. Right? So more geometrical size they need. So geometrical space they need. So then they are getting expanded. So they increase the geometrical shape and size. So that is called the expansion. Right? That happens due to the heat is applied to this body. Right? This will expand. So according to the geometrical shape, the size we consider and geometrical measurement, there are three types of expansions we can consider. If you consider about length, the geometrical measurement, you consider the length. So then we call that kind of expansion. There is a linear expansion. We are considering only one-dimensional expansion, right? So linear expansion we call here. And if you consider about that's a sheet-like object. So in this kind of one, normally they expand to this direction and this about the way. So all the objects they are showing all three-dimensional expansion. But if you consider about the string or wire, the other dimensions are negligible when we consider about the expansion of this dimension towards its length. Consider yeah, it is other dimension or other geometrical expansion is negligible. That's why we are considering the linear expansion for this kind of object. So the sheet-like objects about the way is considerable. So then we consider about area expansion. We are considering this area kind of one. We consider mostly linear. For all the objects, we can consider the linear and everything is there, right? So in three-dimensional object like a cube and the sphere, we consider the volume expansion, right? The area expansion. The important thing is that this statement that's when solid is heated, the amplitude of vibration of atom increases and so average intermolecular separation increases. This results the thermal expansion of solid. So that is the reason for the expansion. So now we consider one by one at the linear expansion, area and volume expansion. Now we can write the experimentally it shows that when you given a heat to a wire or a like object, right? Let's see, this is uniform one length L1, let's see. If given a heat, this length will increase. That means it's a linear expansion. So this increasing amount of the length, that is called the expansion of this delta L, let's say. So experimentally shows that delta L is proportional to its initial length and the change in temperature of the body. So we can say then that delta L is equals to that's the proportionally constant we call it alpha. Here it is proportionally signed now. This is alpha, right? Alpha L1 delta theta. Okay. So this alpha we call the coefficient of linear expansion or linear expansivity, we can call it, right? So this is the main equation. It's corresponding to this linear expansion. So I will go on. So, okay, the linear expansion of solids we consider only the length increase. So here you can see that when you given a heat, the temperature will increase from theta1 to theta2. So length will increase from L1 to L2. So that's the increased amount of the length is delta L. So that is proportional to the initial length and the temperature change, right? So then we can say it's the proportionally constant we consider alpha, that is the coefficient of linear expansion. So then delta L equals alpha L1 delta theta. So the L2 is the final length, that's the length at the temperature theta2. Then you can write as the initial length. Initial length means that the length at the temperature theta1. So it's times 1 plus alpha delta theta. You can write this equation. Delta L equals L2 minus L1. So then L1 take to this side and take it out. Then 1 plus alpha delta theta. So any two temperatures, if you know the length, the relationship between them, you can get using this equation. Right? That's alpha means here it's a very small value, not a bigger one, right? So alpha is, you can consider alpha. Alpha you can write that there is delta L divided by 1 delta theta. Okay. So then you can define this alpha as that is the increase in length or change in length when you change the temperature by 1 Celsius degree for a length of rod of 1 meter per unit. You can consider it as per unit length of rod. We increase the temperature by 1 Celsius degree. The increase in length is called the alpha. Is very small value. So in the order of 10 to the minus 4, 10 to the minus 5, it's much of orders, right? For concrete, we can consider it at 1.1 into 10 to the minus 5 per Celsius. The other materials are also, this is just like a 4 into 10 to the minus 5, 3 into 10 to the minus 5, 1.9 into 10 to the minus 5, like that. It's not a big value, right? It's a value in order of 10 to the minus 4, 10 to the minus 5, 10 to the minus 6 of order there, right? So this definition also given here, that is the linear expansion coefficient. The coefficient of linear expansion of the material of solid is defined as the increase in length per unit rise in temperature, right? So you can write alpha as alpha delta L, L1 delta theta. The SI unit of linear expansion coefficient. Actually, here wrong mistake. Not this per Celsius is not the SI unit, right? You can correct it. That is a Kelvin is the SI unit, right? This is mostly used, right? Global unit is this one, but here it is not different because we are getting the temperature change here. In temperature change, the Celsius and Kelvin are same. Like a 10 degrees Celsius change means delta T is in 10 Celsius degree. It's also equals to the 10 Celsius Kelvin change in uh, 10 degrees change in Celsius is the same. But it is only for change, right? So you don't need to add 273. If you consider body, not the change, that consider the temperature, then it is definitely you need to use the proper unit, right? මේවැදි මේ change එකක් ගන්න හින්දා Celsius change එකයි Kelvin change එකයි කියලා වෙනසක් නැහැ. දෙකේම change එක equal. ඒක keep in mind. මේ එකගේ වැදීම ගන්න පුළුවන්. Okay, so it's depend on the material. So we'll go to this example. You can go there and try to do it, and I will. That's a example. The length of a metal rod is 20 centimeter at 20 Celsius. When the rod is heated uniformly up to the temperature 120, its length becomes 20.05 centimeters. So tell me what is the unit value property of the material of the rod and length of the rod when it's cooled to temperature minus 10 Celsius. You can go through the question and All right. Well, here the given this simply you can use this equation that delta L divided by L1 into theta. Find the alpha. All right. So the length increases is initially 20 centimeters. Now it's 20.05. You can write the 0.05 centimeters the change in length. 20.05 minus 20. So L1 is the 20 centimeters. Here centimeter cancel. You don't need to convert it to the meter. The temperature change is 100. So 20 Celsius to 120 the increase. That 100 degrees increase, right? So then it's equals to the yes 10 to the minus 2, 10 to the minus 2, 10 to the minus 4, 10 to the minus, that is 2.5 into 10 to the minus 5 versus the second part, then directly use the equation right about as delta meter. So this is 20 centimeters, 1 plus alpha is now 2 into 2.5 into 10 to the minus 5. Now temperature change, the final temperature is minus 10 and initial minus 20, right? You use like this. So then it will be negative. If your temperature decrease, the length not increase, it decrease. So that's why you substitute in the proper way, you can get it as negative. This is 1 minus, this is 30 now. This is 7.5, 1 minus 7. 7.5 into 10 to the minus 4. And then you can make it a negligible kill apparent way. Simplify කරලා estimate කියන්න වෙනවා. හරි මේ වගේ ගණන් එක වැඩි වෙන එක it's not much bigger value. Actually it is smaller value. If you with the answer you can get is 19.985. Right, that is in centimeters. Okay, that small amount will it is. So on this day you need to write it. Okay. Calculate this all and then go to the next one. Right, then expansion of sorry. As I mentioned earlier, that's if the geometrical measurements you consider as area. So that expansion we call the area expansion. Right? It's two-dimensional now. The sheet-like objects we can consider like this way. So here you can draw this diagram. I'm not drawing here. So I think you have the sheet-like object which having the area A, and if you when I heat, let's see it's temperature increase. So here the temperature at theta1 and area is let's say A1. Temperature increase, right? This is heating. By heating, its area becomes let's say A2. Okay, its area will increase. This is the initial area chest. This much of area increased. That is the increased area or change in area. So there, according to the experimentally also we can say that the increase in area that's also proportional to the initial area and the temperature change. Temperature change is equal to the theta 2 minus theta 1. This is at theta 2 temperature. Okay, you can write this as then experimentally. That delta A proportional to A1 delta theta. So introduce another proportionally constant that's beta, that is then delta A1 delta theta. So this beta we define as that is the area expansion coefficient. Coefficient of area expansion. Right. This is also same as alpha. The unit and unit is same, but the value will differ. And then this delta A equals that's A2 minus A1. So we can write this A2 minus A1, that's equals to the beta A1 delta theta. So we can use this equation as a fundamental, so then you can directly use it. So here then you can write this A1 to take to the side, and you can write this A2 equals A1 times 1 plus beta delta theta. A similar equation, similar shape of equation you can get. Only the beta will change here. That the beta we consider, so you need to consider about the area expansion coefficient of the given material, not the alpha. So this way you can use this, right? You can draw this and write down. So something you don't have time to get a print out, so then you can write it in the book. If you want, take it later. Okay, I'll clear this on. All right. If you have any questions, you can ask. Right? Message then definition of this area expansion coefficient is also can define similar way. That's the beta we can write, that is the change in area divided by the initial area multiplied by the temperature change. So you can define it as previously we defined alpha. Remember, is the expansion of the area or the increase or decrease of change in area per unit area of object per unit temperature rise. It's 1 Celsius temperature rise. If you can, then at this point you can say that if the temperature of the object increased by 1 Celsius degree, width of the 1 square meter of area is increased by 1 Celsius degree. Area increase is called the beta. Okay. You can write that way. You know, that's right. The beta of the area expansion coefficient is as the increased in its area, surface area, unit area per unit rise in its temperature. Rise in its temperature. So its side it is also beta is also this per Kelvin. Right? So it is also in order of 10 to the minus 4, 10 to the minus 5, like so small, right? As it's so small, you can write the square of beta over cube of beta. Approximately it's 0. Not the first order, that's the second order, the other higher orders you can consider it as 0. For alpha, beta, and next one is also you can consider all the higher orders are 0. But they're so small because 10 to the minus 5 square of this is 10 to the minus 10. So it's all small, it's negligible. We can consider about the 1. Pairing with 1, it's so small. And also in this lesson, you need to know that if 1 plus x to the power n type, this kind of expressions we have, let's see. If x is so small than this 1, then you can write this 1 plus x to the n. That's approximately equal to 1 plus nx. Because other one come with this higher order of x. So the neglect this like this. So then you can consider only this first order one. This mathematical trick you need to keep in mind. It will be much easier to do some simplification. So, okay, we'll go to the next one. This thing we discussed. We can prove that beta equals to alpha. That is for the same material. The linear expansion coefficient and beta, the area expansion coefficient. The relationship like this. The area expansion coefficient is twice the linear expansion coefficient. Alright, same material only, right? We cannot write it for the materials. I'll show you this. Let's consider I'm considering a sheet of area. One is coming, right? The sheets of area. This side is 1 meter, then this side is 1. The unit area I'm considering. So area of this one is 1 square meter. 1 square meter. Right? At the temperature theta list. Set temperature theta. So I increase the temperature by 1 Celsius degree of this So then now the temperature, new temperature is, that is theta plus 1, right? You increase the temperature by 1 Celsius degree of a 1 meter length of a rod, so its length increased by alpha. That is the definition of alpha. So you can write this side length is equals to 1 plus alpha. And for this side also, that length is equals to the 1 plus alpha. That's in meter. If you consider about the unit length, that the temperature is rise by a unit degree, 1 degree. So then length is increased by alpha. That is the alpha, the linear expansion coefficient of the material. So then in this case, now the second area is equals to 1 plus alpha square. That's square meter. Okay, then use the equation that is A2 equals A1 times 1 plus beta delta theta. Delta theta here it is 1 Celsius degree change. You can write like this. The A2 now you can substitute that 1 plus alpha square and A1 is 1 square 1 plus beta here. And you can simplify is 1 plus 2 alpha plus alpha square, that's equals to the 1 plus beta. So it gives you that the beta equals alpha square plus 2 alpha. So as alpha is very small, and write that the alpha square is approximately 0. Very small means 10 to the minus 5 or 10 to the minus 4 like values. The square we can consider it as 0. So then this term you can consider as 0. So then the remaining one beta is equals to the 2 alpha. So that's the way you can do this beta equals. You need to keep this in mind because in some equations they are given the linear expansion coefficient only if you want a beta. So then you need to multiply it by 2 and then substitute. Because most students they forgot to substitute they are going to have substitute values as the given. But in beta alpha given, you need to consider about beta. So you need to multiply by 2. Okay. Underneath. Then you can. And this volume expansion function, right? It's also similar to the previous one, but different. That's we consider the volume. Yeah, X. So we consider volume of an object. Let's say this volume is V1 at the temperature theta 1. So you increase the temperature of this then it's expand, the volume will be increased. The same thing happen when the temperature reduce, so that will decrease volume. So whenever you can apply the equation, right? So the V2 it's become V2n at the temperature theta 2. The theta 2 is greater than theta 1. So experimentally we can show that the volume increase is also proportional to the initial volume and temperature change. So you can write this delta V is proportional to the V1 delta theta. So it's proportionally constant. You can introduce to there. So in the delta V that's equals to the gamma V1 delta theta. So this is the equation for the expansion, and this gamma we consider this gamma is called the coefficient of volume expansion. Coefficient of volume expansion. So gamma. It's also a SI unit of this is similar to the previous alpha beta per Celsius. It's also the smaller value. Need to know, right? So then this equation you can rearrange like this. The delta V is the V2 minus V1, so it's equals to the V1 gamma delta theta, right? So then the V2 you can write V1 times 1 plus gamma delta theta. So this way you can use this equation, and to find the volume of a given temperature, if you know the volume at the remaining temperature, you can use this equation to find. Gamma is also the small value. You can write it down there. Okay. Kalau print out akan berkenaan arke dijaga nona kalau ke screenshot tag hai itu dia pasti ada dijaga. Oh ini nak. Healthcare is also right. And definition also similar to this. Now you know that you can write it in yourself also, right? So the gamma equals then delta V over delta theta. So it's definition you can write there is increase in its volume per unit rise in temperature is called the volume expansion coefficient of the material. Decrease its volume of material or substance per unit volume per unit rise in temperature. Or volume expansion coefficient of material of the substance. Right? So this way you can find it. So gamma this size is also per Kelvin. That's also a smaller values. So you can consider gamma is tau, gamma cube, 0. Okay. Then also we can prove this gamma is 3 times of alpha for a given substance. So we can write like this also. Right? So that's proof is similar to the previous one. we can do it same manner. So consider the length of 1 cubic, sorry, volume of 1 cubic meter of cube meter length. Side length is 1 meter. Like this. So then its temperature, let's say it's increased by 166 degree, and then it expand. Okay, first this side is 1 meter, 1 meter, 1. So in the initial volume is 1 cubic. Temperature is rise by 166 degree. So then its length become 1 plus alpha meter, 1 plus alpha meter, and 1 plus alpha meter. So all sides is increase its length by alpha because of the definition of alpha, right? So this volume is now it's 1 plus alpha cube. Then you can use this in this equation. It's gamma delta theta. So the V2 is 1 plus alpha cube. V1 is 1 and 1 gamma, and the theta is 166 degree change. And by simplifying this, 1 plus the 3 alpha plus 3 alpha square plus alpha cube is equal to 1 plus gamma. So when it the gamma then equals to the 3 alpha plus 3 alpha plus alpha cube. So the higher orders of the alpha and higher orders means alpha square and alpha cube can consider as 0 because they are very small. Then you can write this gamma equals 3. So that's the way. Then you know that alpha equals that beta equals 2 alpha and gamma equals 3 alpha. So these are the that's expansion of solids, right? So in 3 dimensionally we discuss all the cases, and it's all the materials they expand all the directions at all dimensions they increase when it's heated. But you need to keep in mind then in any case you can consider, if you are considering about its length only, you can consider the linear expansion. If you want to consider the area also, you can consider its area expansion, and only volume you consider, you can consider the volume expansion. So that's all, right? So we discuss some examples. Okay, and then we go to the next one. There's some applications here related to these many applications. I'll give you the question. Right. Okay. Some small things simply given you. When you consider about the, let's say, the ring-like object. So I'll erase this now. It's finished. The field part about this one. Think we are considering about this ring-like object, right? So here its radius considering like this r, let's say. So the length of this one is 2 pi r. If you increase its temperature, then it's increases. Now it's the radius become r dash. Now the new length of this cell dash is equal to 2 pi r dash. If you apply this linear expansion equation, that's plus delta theta, that's alpha times delta theta. One and this theta two, let's right, equals 2 pi r dash. You can write it's 2 pi r 1 plus alpha delta t. So 2 pi cancels, so then r dash equals to r naught. So in this kind of cases, instead of considering the length, you can write the equation by considering its radius. Okay. So you can use in this way directly, you can apply it's for the radius. It's much easy. And this I'll do the question. Write the first question at 20 Celsius. At 20 Celsius, a brass cube, a brass cube has edge length as the length 30 centimeters. What is the increase in the surface area? What is the increase in the surface area when it is heated from 20 to 70 Celsius? When it is heated from 20 to 70 Celsius. Linear expansion coefficient of brass, that is 1.9 into 10 to the minus 5. Okay. So linear expansion, you can find it. Okay. To see. So to calculate that the glass cube has a extensive charge and what is the increasing surface area. So you can first find the area expression. Cube now. This third is is the initial one surface and one plus beta is 2 alpha 1.5 50 temperature change then 70 20 to 70 is 50, right? You can find this. So this will be 100.71 and take the square root of this, then you can find the it's a now new side name or each length, right? So it will be approximately that is 30.03028. So that was centimeter. This is actually okay. Length surface area. That there are 6 sides in that is a area of one side. So the total surface area is 6 times of this. So it will be 54,410.7. The initial surface area is then total surface area. It is 900 into 6. That's 5,400. There's a change in the increase in area, that is 10.26. Right. Very well. Is it clear? That's then you can discuss this. I will check. I will already given you the tutorial and go through that question number 12. And these values, given the table there, linear expansion property, you can take it from the table, right? And question number 12, you do. Then question number 20, 21, 21 is parameter x. 21 question is going to show that x graph equals b minus q is 4x diagonal for 4 arbitrary. 23 diagonal, say 24 diagonal. And 28. Number 28. 28. 4. Opposite 28. Google period again. 23. Eric Karma, I'll give you the 15 minutes to do this, right? 15, 20 minutes then. හල තත්ත්වකින් තගාලන විනාඩි දෙකෙන් අර මම ප්‍රශ්නයක් තිබ්බොත් මම මැසේජ් එකක් ෆෝන් එක පල්ලෙහාට අරන් ගිහලා එන්නට බලහන් ටික ඩිස්කස් කරලා ඊට පස්සේ applications of expansion කරනවා ඊට පස්සේ liquid expansion කරනවා එච්චර වෙලා නැහැ මේ I'll send the presentation for this one also. I had the presentation. I will send you that. හරි බලමු. Then wait. A circular hole in an aluminum plate is 2.725 centimeters diameter at 0 Celsius. And what is its diameter when the temperature of the plate is raised to 100 Celsius? I'm going to tell you that that's finally I will still this one. The 12th one we'll do later, right? I will give you that when you are writing these kind of questions in a hole in a plate, you consider that hole is also filled with that material and then write the equation for that hole part. You can write it as area expansion and then take a example. If I consider this diameter is d, this area will expand, let's say 2% a1 plus sorry a1 times 1 plus b direct theta. You can use this. I will go to this on the other side. 12th one. The hole is there. The diameter, let's see. Write the equation for this hole. You can consider that the material is filled with there, right? The C2 finally, let's see, it is 5r square pi d over 4 square. So the new diameter I'm considering as d dash. Oh, that's square of that, right? So I will take it as d2 easy. D2 oh, that's square of that, right? So initially it's pi d1, let's say 1 plus beta is 2 alpha because this is aluminium. Aluminium has 2.3 into 10 to the minus 5. So I write is 2 into that's 2.3 into 10 to the minus 5. The temperature change 100 degree of Celsius. So the new diameter you can write it. So D1, that's the value, you know, finally we substitute this. This one, I will arrive 1 point milligram 46. Then NF 4.6 into 10 to the minus 10, 0.0046 into 10. So the T2 is the square root of this 2.725 centimeters multiplied by the square root of this one. It's 1.023. 0.023. Let me multiply by this is a new diameter of that hole. The hole එකක් තිබ්බොත් ඔය හරිය plate එකක් හරිය මේක ඒක මතක තියාගන්න. hole එකක් එහෙම gap එකක් cavity එකක් තිබ්බොත් you can consider that cavity is filled with that material and then you can use the equation for that cavity to the material. හරි ඒක expand වෙනකොට මේක මෙහෙට expand ලා අඩු වෙන්නේ නැහැ. The diameter also increases. හරි නේද ඒක? ආධාරි ප්‍රශ්න තියෙනවා අහන්න. 15th one, so define the linear expansion coefficient of the material. We already given that theory part. I'm not going to discuss. The question part of this. The length of the metal is 50 centimeter 30 and the length was increased by 2 millimeter when its temperature increased 130. So what is the length of the rod at 70 and what is the length at 0? So go to the next one then. Length is increased by 2 millimeter, that's 50 centimeter one. So first you find alpha. The increase in length is 2 millimeters to the -3. The initial length is 50 centimeters into the -2. And the temperature change is 100. Here I'm using this equation that delta L over L1. That's theta, right? This I'm using here. The increased length is the 2 millimeter and this 50 centimeter. I use the meter because it's not same. Equals to 4 into 10 to the minus. Five. Then find the length at 70. This is initially 50 centimeters, 1 plus alpha. And 70 Celsius means 30, 40, 30 to 70 is 40 Celsius degree change. You can substitute and then get the answer for this. So this is 50.08. Second at 0 Celsius, so that is 51 plus 4 into 10 to the -5 plus 40. Here it is now is a -30 because temperature is reduced by 30 degrees to become 0. So it is 1. So and is the 49.94 centimeters. These are the answer. That is the 15th one. I asked you to do the question number 21. That's 20. That's 20. A star metal sheets of side length is A and the linear expansion option alpha 1 is needed to insert into a frame of side length B. And linear expansion coefficient A2. So that's the temperature which you needed to be heat both the sheets and the frame is this one. You have the square sheet of side length is A and linear expansion is alpha 1. Right. And also here you have a frame. Frame on the right. Side length is B and this linear expansion coefficient is alpha 2. If you want to make this frame, fit this frame to the sheet. So my heat now make it. Right now the new the game and then this should be become same. මේ length එක කියලා ගන්න මේ ඇතුළේ තියෙන cavity length එක විතරයි. So at that temperature here, this is theta 1, let's say. At theta 2 temperature, the both the sheet and the frame should have the same length. Right? I will take it as a B. Let's say the L, the length of that. So then we can write the equation for this. Right? For the frame, you can write that's the length is equal to the initial length times 1 plus alpha delta theta. That's theta 2 minus theta 1, right? This delta theta we need to find. And for the sheets, you can write this area because it's a sheet. Then you can write this L square, this should equals to the A square initial area 1 plus beta, that is alpha 2, and this is for the sheets, it's linear expansion alpha 1, so this should be 2 alpha 1 because the beta equals 2 alpha and this temperature change. All right, and this L square you can substitute this, so this is then B square 1 plus alpha 2 delta theta, the square of that A square 1 plus 2 alpha 1 delta theta. Now you can square in this higher orders you can neglect, so then this square you can write the B square 1 plus 2 alpha 2 delta theta, and that's the part right there, that's alpha 2 square delta theta square. So the alpha 2 square is much smaller, so you can consider this as 0. Consider this part that's equals to 0 because alpha square is so small. You need to write that reason, but the reason I'm writing there, that's alpha is very small. So then the alpha square 0. So after this, you can simplify and get the answers given. This 2 alpha beta square 2 alpha 2 delta theta. Here also A square 2 alpha 1 delta theta. You can take delta theta out. Then you can write there. මේ පැත්තේ තියෙන ටික මේ පැත්තට ගෙනවා කියලා හිතමු. මේ පැත්තේ තියෙන මේ ටික. ඒකට මෙතන ඉතුරු වෙන්නේ මේක ගත්තාම දැන් මේක 2 එළියට ගන්න පුළුවන්. alpha 2 beta square B square. අර පැත්තෙන් ඉදී alpha 1 A square. මේ පැත්තේ එක වැඩිවම A square යනවා. එයා පැත්තේ B square මෙතන. That is A square minus B square. So then the delta theta is equals to the A square minus B square divided by 2 times the alpha 2 B square minus alpha 1 A square. So this answer is the answer they ask you to show. It's 21. Triangular frame is made by 3 rods AB, BC, and CA. Is it okay for this? I will go to the next page. The point A is connected to the point B. It is the midpoint of the rod AC. The rod AC that's equals to AX. Okay. It's not changing its triangular shape when it's sitting, so that 4 is extra when on the 1 2 and then option AB and AD is B. The rod BC is R and the rod given this part. Another these two A, C, and this is D. It's a midpoint of BC, so these are equal. and this side equals to this side also. This is given as x. This is given as y. This is y over 2, and this side is y over 2. This is AD. This perpendicular now, you can say. And this AZ, AB and AD. එතන පොඩි වැරද්දක් තියෙනවා. AD දෙකක් තියෙනවා. AB and AC වෙනවා. Equal එක තමයි P කියන එක පොඩක් හදාගන්න උත් එක. This is P and this is P, the linear expansion coefficient. And BC is R. This one has R, and this is Q. The ED දෙකක් තියෙන ED වෙනුවෙන් AB. So that's the equal length. This shape will not be changed after expansion. මේ shape එකම තියෙනවා කියන්නේ දැන් මේක perpendicular වෙන්න. According to this, you can write using the Pythagoras theorem. Right? This AD. Let's say this length is L කියලා මම ගන්නවා. This L square plus y over 2 square should be equal to x square. Then so that's L square equals to the x square minus y square over 4. My linear relation. Make it expand normal. Let's see this length AD become that's L dash. Make x dash, make a y dash on algorithm. Or a shape එක ඒ විදිහටම තියෙන නම් ඒක මේ විදිහටම මේ shape එකම තියෙනවා කියන්නේ you can, that's a Pythagoras theorem can be solved for the after heating also, right? So I'll write then if the shape is not changed, change Pythagoras theorem. Be applied after heating. And be applied after heating also. Then you can write the equation that's I'm writing after heating. This the length will come L dash. So that's L dash square plus y dash over 2 star should be equal to x dash. You can write the equation that's L equals dash equals L times 1 plus alpha delta theta. This relation you can write for this all then. The L dash you can write that is L times 1 plus its linear expansion coefficient is Q delta theta. The square of that. The y dash you can write as y dash of 4 here. So I'll write this 4. It's equals to this length is y over 2. So it's initial length you can take as y dash. I'm writing here y dash. That's y kilo. What's the y square around 1 plus y kilo got the main rod again. Linear expansion like r delta theta. That should be the x, that's initial length 1 plus b delta theta. So square of this. All right. Then simplify again. Delta theta. Make a small values of small in the element make a 1 plus 2q delta theta. Y star 1 plus 2 r delta theta. Higher orders ටික මේ අයින් කරලා දෙන්න හරි. Higher orders ටික අයින් කරලා මේක expand කරලා higher order 0 ඉන්නේ ඒවා අයින් කරනවා small values එක. මේක පාරට ලියලා දැන් මෙතන total මේ term ටික එහා පැත්තට මේක කරයි. 2q delta a ටික අපි ගන්නවා මේ පැත්තට. delta d නේද ඔක්කොම මේ පැත්තට ගන්න. ඒ ටික ඔක්කොම එහා පැත්තට. මේක මම මෙතන ලියනවා L square into the 2 theta L square. Make L square again have it again. Then you know 2 theta y square over 4. Back to the enemy, maybe 2p into theta x square. That's maybe the x square, you have at the made L square minus y square over 4. The L square can x square minus y square over 4. The big method substitute karama made it capital. They are 0. Make any comma may have at the make it equal again. 2 delta theta is all cancelled. Simple like better than 0. You can cancel now 2 delta theta, 2 delta theta, 2 delta theta. यहाँ बेहतर में x का can take this within L square to make a substitute करने सर. So let's give you can write as x square minus y square over 4. This r y square over 4 minus px square is equal to 0. Okay. Now take this x square to one side. Maybe better now. The x square you can take out. So then the p minus the value the y square or you can take out. R minus q so a simplification theoretically you need to get this one. When it is heated, if the shape is not changed, means that's the same mathematical relation. That's Pythagoras theorem can be held at any temperature. So that's right. 3 by 21 now. Okay. 20, 3, 4, 5, 3, 4, 8. 23 here, let's see. There's 2 dots ABC. I think ඔය විදිහට තමයි කරන්න තියෙන්නේ හදෝ ඊළඟ කිත්තේ ලොකුෙන් ගන්න එකක් ඒ වගේම තමයි 23 එකේ 28 xy equal equal කරාම ඔක ඔය කියන ප්‍රශ්න එකක් හරියටම කරන්න ඕනේ. Next questions කරන්න මම theory ටික පොඩ්ඩක් තව කියලා හරි ඔයගොල්ලෝ ඊතර questions ටික කරන්න theory application ටික කරලා ඉන්නම් ඉස්සලා. Right, I will share with you this application. It's up here. Right. So now WhatsApp is there, mommy. some applications of this expansion. So one is this biometric strips. That is two strips with connected parallelly the two dissimilar materials. You can see here then if the linear expansion coefficient is different, right? This is a linear expansion coefficient are different of these two materials. There's brass and steel mostly used. So that's one. If you heated these two strips together with one to a one temperature, same temperature change, the one strip is expand more than the other because one has the alpha greater than the another one. Greater than alpha one, it's it'll be the outer one. This is alpha one. This is alpha two. So if alpha one is greater than alpha two, when the temperature increases, it bends like this because the outer one again length එක වැඩි යා තමයි වැඩියෙන් expand. මෙයා length එක අඩු වෙන යා අඩුවෙන් expand. So more expansion this way that side it's curved to the other side, right? The temperature එක අඩු කරොත් එහෙම ඒ අනිත් පැත්ත වෙනවා. Right. So that's a biometric strips. So we can use this to automatic switching when the temperature as a temperature sensor. Okay, electric iron so ඉස්සර තිබ්බේ දැන් නම් digital එනේ එක පොඩි semiconductor items තියෙනවා. ඉස්සර අපේ තියෙනවා ඒ වගේ පොඩි biometric strip එකක් තමයි තියෙන්නේ. temperature iron එක ඕනකට වඩා heat වෙනකොට අපි දැන් මොකක්ද temperature control කරනවා. heat වෙනකොට වෙන්නේ heat එක වැඩි වෙච්ච ගමන් this surge මේක මෙහෙම මේක අර bend වෙනවා. එන්න මේ switch එකේ මේක යනවා මෙහෙම. So then the automatically switch off වෙනවා. يعني ඒක එතනින් හරි heat වෙන්නේ නැහැ. ඊට පස්සේ මේක cool down වෙනකොට මේක ටික ආය වෙලා ආයෙ මේ switch එකේ වදිනවා. වදුනහම ආයෙ on වෙනවා. on වෙලා ආයෙ heat වෙන්න පටන් ගන්නවා. ඒක heat එක වැඩි වුණාම ආයෙ අර වගේ වෙනවා. ඒක තමයි ඔය කියන්නේ. තියෙන්නේ. අපි දැන් ඒක අපිට ඕන රේල් එකට කරකවනවානේ. ඒ කරකවුවාම මේ switch එක අපි ඕන ගන්නට උඩට පල්ලෙහාට කරන එක තමයි කරන්නේ. ඒකට ඒක ඇවිල්ලා වදින තැන අපිට set කරනවා. දැන් මේකේ මේ බෙන් වෙන ප්‍රමාණය නැත්නම් diffraction එක මේ කොච්චරක් එතනින් මේව බිලා මේ විදිහට පල්ලෙහාට ගියාද කියන we can calculate. right? තමයි basic application එක calculation side එක අපි චුට්ටක් මම calculate කරන්නේ actually ඔක equation එක මම දීලා තියෙනවා මෙතන මම I will do it here. ඊට වගේ ඔයාලට නම් උදේ නියඳි දෙතුයි මම මේක white board mode එකට රන් දෙන්න. මේ biometric structure. Right? So I will show the biometric structure. So this one is alpha 1 and this alpha 2 the linear expansion coefficient. The diameters can consider the same diameter or different diameters. Take D1 and D. D can come on. Yes, sooner to other take the diameter. Length is it. When the temperature theta, if the temperature increase, this will be curve. Oh, we got one. මෙහෙම තියෙන්නේ. මේක දර මෙහෙම කව්. මේක alpha 2 less than alpha 1 again. Right. At the end of this discussion, I'll add the one which 86. But I make a curve with it's a circular shape. That's entirely like by this. It says its radius is r. So this angle, let's see. I have become delta here. Angle like. So the මෙන්න මේ තුරමයින් ඕනේ මේ strip එකේ හරියට මැදට. And this, let's say this is 2. The method and length that is S1. Making me arc length එක ගන්න ඕනේ strip එකේ මැදට කියලා මතක තියාගන්න. මේ radius එක මැනලා තියෙන්නේ මෙතන මේ strip දෙක වෙන් වෙන තැනට. හරි. ඒක මතක තියාගන්න. හරි. එහෙනම් තමයි දාගන්න ඕන රූපය දෙදී එහෙම දාගන්න. හරි. ඒතර මේක D, this side is D. but මේ හරියට මැදටමයි දුර වෙන්නේ SDO2 විදිහට දෙපැත්තට. එතන මේ ස්ට්‍රිප් එකේ මැදට තමයි මෙතනට තමයි රේඩියස් එක R කියලා අරන්. හරි. නැත්නම් මේක රෙෆර් කරන්න බෑනේ. alpha 1 this alpha 2 S1 corresponding to the arc length of the alpha 1. That's other one, S2 is C. So you can write in this S equals R theta. Equation. So then S1 equals, that is R radius for that is R plus G over 2. Theta. Theta means here delta. Again, S2 you can write that is R plus, sorry, R minus. R minus T over 2. Yes. Then D1, D2, this D1, this is D2 like that. Okay. The ratio of these two you can write in R plus T over 2 divided by R minus T over 2. And also, you can write that S1 equals the initial length L, 1 plus, that's alpha 1 delta theta. And S2 you can write L, 1 plus alpha 2 delta theta. The ratio of these two, you can write L cancel. So then you can write this equation 1 plus alpha 1 delta theta divided by 1 plus alpha 2 delta theta. So using this equation, I'm not going to calculate, you can calculate the R. What is the R? If the elements are given, you can find the R. Simplify cross multiply this you can subject that. Mama you need to do it using mathematics part, right? If the given the values they given, you know how the values to know, you can easily you can find it. You can find the R from. Then according to this figure, this is a right angle triangle. So this distance is toward is x. So this x, you know, that's this length is then center method that is R minus x actually. R minus x. And this is R and this is L. So you can use the Pythagoras theorem for that. You can write in the R square equals R minus x square plus L square. So then R square, that is R square minus 2 Rx minus plus x square L square. This x square is so small, so you can neglect that part also. So cancel. And x square is much smaller than this L square. So this you can consider that x square as neglect. Make a neglect like mega meter gana path in so it's 0. Be comparing with this. And this part then go to the other side, that is 2Rx. So then you can write x equals L square over 2R. You can find R from here, that's distance is lower, you can find this. So that's how we can apply this expansion of linear expansion for the biometric history. Okay, then go to the next application. The thermal stress in a rigidly fixed zone. The last day we discussed this part under the elasticity method also. If the rod is free to expand, we need it to expand. Right? It will change. But if that rod is fixed at the both end, so they don't have any freedom to expand. So what's happened then is against the expansion, it will stress. Like they apply the force on the both end of the rod, but they don't have enough space to expand. And if the temperature adu karama, yeah, they know it. So if you increase the temperature, the temperature very good. Then anybody, so then they didn't make a make a මේක අඳුරද දීගේ වැඩි වෙනවා වැඩි වෙන්න freedom එක නැති හින්දා මේ විදිහට force කියන්නේ දැන් යා මෙහෙට තල්ලු කරනවනේ මේ තල්ලු කරද්දී එයා උඩට force එක එනවා අනිත් පැත්තට contraction එකක් වෙනවා the temperature වැඩි කරනවා so that's the temperature delta T increase කරනවා temperature එක අඩු කරොත් එහෙම ඒක අනිත් පැත්තට මේ අඩු වෙන්න බෑ මේක අඩු වෙන්න බෑනේ දැන් ෆික්ස් කරලා තිබ්බොත් දෙපැත්ත මේක මෙහෙටයි දෙන්නේ එතකොට මේක මෙහෙට අදිද්දි මේ සපෝට් එකේ මොකද ගන්නෙ රොඩ් එක ටෙන්ෂන් එක කරලා so it tension මේකේ ෆෝස් එක මේ රොඩ් එකට ෆෝස් එක එතකොට එන්නේ මේ force experience, let's say the next. If there's a freedom to expand this delta x, you can write that's equal to the initial length, the linear expansion coefficient, and delta theta. Temperature change. Delta T means that the delta theta, you can use delta theta. And if the force experience on due to this expansion, we extend වෙනවා නිකන් force එකක් දාලා ඇද්දොත් ඒ length එක වැඩි වෙන එක that's by the Hooke's law you can write දැන් lesson එක කරලා තියෙන ඉඳන් කෙලිම ලියන්න so that force experience that's stress that's equal to the Young modulus into changing that's a strain changing length divided by the initial so then this delta L here you can experience that if there is a freedom to expand, that is the delta. So you can consider that the same phenomenon is applied if it is increased by the length delta x. So it's similar to if you apply the force delta x to extend the rod by the length delta x. Make a delta x then the adipu force එකක් දුන්නා නම් එදෙන delta x එක මෙතනදී ඒ length එක expand වෙන්න ඉඩ දෙන්නේ නැතුව තිබ්බොත් එන apply වෙන force එකට equal කියලා we can assume so then you can apply this x delta L here using this equation right let's say delta L over L that is alpha delta theta so then you can say that the force experience or the stress produced is equal to the y alpha delta theta so we can write the force experience on into the ay alpha delta t. So here alpha is the linear expansion coefficient of this material and y is the Young modulus, a is the cross sectional area and theta is the temperature change. So that equation you can apply in thermal experiment. Okay. So here you have to write this. Wait, we have to make a current. I'll go to the next part then. You have video example here. To try to do this example, you have to try to learn along. I will explain it in the next video. Theory class to give it a down in the class. Maybe try to make it permission තිබ්බනම් ප්‍රමාණයක් යම් ප්‍රමාණයකට ඒ ටිකට expand වෙනවා ඉතුරු ටිකට තමයි as example let's say side එක දෙන්නම් කරන්න හැටි දැන් මේව fix කරලා තියෙන rod එක හොඳියා දැන් මෙතන තියෙන්නේ මේ අතර තියෙන පොඩි gap එක මෙතන මේක 5 mm allow කරලා තියෙනවා දැන් අපි හිතමු මේක temperature එක increase කරාම 10 mm expand වෙනවා කියන ඒතකොට 5 mm වලට එනකන් කිසි ප්‍රශ්නයක් නැහැ ඒක expand වෙනවා. ඉතුරු 5 mm වලට තමයි thermal stress එක build up වෙන්නේ. ඒතර ඒ ටිකට විතරයි ලියන්න ඕනේ. අන්න එහෙම ඔක කරන්න ඕනේ. හරි. hint එකක් දුන්නේ you can do in that way. ඔයාලා ඒ ටික කරලා මේක examples ටික you can take a screenshot and send me, then I will check and then discuss. Okay, this is the error in reading due to the expansion of the contraction because normally in the wooden the strip scales ගත්තොත් meter rules එහෙම ඒවට නම් ලොකු බලපෑමක් නැහැ. but in the metallic strips වලට ගත්තාම temperature එක වෙනස් වෙනකොට ඒකේ ඒක expand වෙනවා, temperature අඩු වුණොත් ඒක contract වෙනවා. එතකොට වෙන්නේ එයාගේ reading එක වෙනස් වෙනවා. දැන් මේක තමයි රූපිතා තියෙන එක වෙන විදිහට පැහැදිලි කරන්න මෙතන. මේක තමයි scale එක කියන්නේ. මේකෙන් අයිනවා කියලා length එක මේක තමයි. මේ විදිහට එන්නේ. then මේක තමයි scale එකේ ඔයා මෙතන read කරලා this is the actual value or true value. That is I mentioned here that TeV is a true value. මේක හදපු temperature එක කියලා හිතන්න. මේ strip එක හදපු temperature එක. එහෙම කියලා. And if the temperature is theta, now the temperature increase. මේ scale එක expand වෙනවා. මේ A scale එක expand වෙලා දැන් තියෙනවා. අපි හිතමු අර length එකමයි අපි mind යන්නේ කියලා කියන්නේ. මේ දෙකම එකට වෙන්නේ දැන් මේ අපිට හම්බ වෙන රූල කොයි temperature එකද හැදුවේ කියලා we don't know that. දැන් නෑනේ කොයි temperature එකද ඒක අදාළද කියලා. අපි මනින්නේ දැන් ඒක UK වල හැදුවේ Celsius 10 15 වගේ temperature එකක් තියෙන වෙලාවක කියලා. අපි මේ දැන් මේක mind පාවිච්චි කරන්නේ 30 Celsius වල. දැන් එතකොට අපිට බලන්න ඕනේ දැන් අපි ගන්න reading එක එතකොට ඒකේ ඇත්තට වෙනසක් තියෙනවා. ඒක අපි මයින් එක ඒකමයි දැන්. හරිද? ඒක වෙනසක් නැහැ. ඒ length එකම තමයි. හැබැයි දැන් මේකේ පෙන්නන value එකේ වෙනසක් තියෙනවා. දැන් මේක expand වෙනානේ. expand වුණාම දැන් කලින් මේ true value එක තිබ්බ. ඒ කියන්නේ මේක පෙන්නපු scale එක දැන් තියෙන එතන නෙමෙයි. දැන් expand වෙලා දැන් මේ හරියට මේක ඇවිල්ලා. දීග වෙලා. හරි. දැන් scale එකේ reading එක දෙන්නේ මෙහි. හරියට ඇවිල්ලා කියලා. දැන් මෙතන read පෙන්නන්නේ යගේ දැන් කලින්ට වඩා මොකද තියෙන්නේ? අඩුයි. This is a scale reading. මෙතන තමයි true value එක තියෙන්නේ. ඇත්තටම read කරනවා. Right? So then this small part, this is the part is expand. So that's expansion part you can write in the initial value, that is this true value TR TV කියලා එන එක. Sorry. true value එක මෙතනදී වෙන්න ඕනේ. දැන් මෙතනනේ අපි read කරන්නේ මේක හදපු temperature එක නෙමෙයිනේ. dash let's say. So it is a scale reading එක. දැන් scale එක පෙන්නන reading එක. So 1 plus alpha delta theta. It should be there. So this delta L equals to EV minus S star. So then the true value you can write then is S star. Sorry, here mata value na. So that's the delta L equals that is S. EV minus S star. So here this is equals to the that's actual value එක මෙතන start දැන් scale එකේ read කරන value එක times alpha and delta. So then the true value you can write that is a scale reading 1 plus alpha delta t. ඒක true value එක මොකක්ද කියලා හොයාගන්න. ඇත්තටම read කරන්න. ඒ කියන්නේ අපි read කරනකොට අපිට පෙන්නලාගේ තමයි මෙතන තියෙන්නේ. but actual value එක මේක expand වෙලා තිබ්බනම් ඒකේ තියෙන්නේ මේ. ඒක negative කියලා දානවා temperature එක අඩු වුණාම එතකොට ඒක අඩු වෙලා යනවා. තේරෙනවද? ඔය වගේ මේකක් කියන්නේ. scale එකක් වෙනසක් ගත්තොත් you can identify it and then you can reading එක scale එකේ read කරන තැන වෙනස් වෙනවා. අපිට පෙන්නන්නේ ඇත්තටම වෙනස්. පේනාගේ නෙමෙයි ඇත්තමගේ කියන්නේ. scale reading is not the actual value. Its true value is little different. Because it's not, if it is given a same value when the same temperature you measure, if the scale is made at the temperature 15 Celsius, let's say, if you measure the length at 15 Celsius, then it is okay. That's the same value it shows. But with the other temperature, it's showing little bit different value. It's clear. So I'll clear this out. Go through this example also. You can send me the answer. ඔය ටික කරා එවන්න ඒගොල්ලන්ට මම ඒක බලලා ගලා කියන්න මම next class එකේදී තමයි ඉස්කෝල පටන් ගන්න examples ටික මම කියලා දෙන්නම්. This thing I already give you. That's it, right? මේ cavity එකක් එහෙම නැත්නම් hole එකක් gap එකක් වගේ එකක් තියෙනවා නම් so you don't need to worry about it. You have to consider that this gap is also filled with that material and then write the extension. According to that, I here mention you this make a Hoy street again. This part is removed. That's the B easier. Expansion මේ hole එක expand වෙන එක මේ material මේ tip එක expand වෙන එකට equal කරනවා. ඒ කියන්නේ hole එකට material තිබ්බයි කියලා හිතලා equation ලියන්න පුළුවන්. එතන මෙතනක් තියෙන expansion එක මෙන්න මේ මේක අයින් කරාට පස්සේ තියෙන මේ කොටස ඉතුරු වෙලා තියෙන ඒක expansion එක මේ full අර මැද ටික පිරීලා තිබ්බාම එන expansion AB size එකටම equal. ඒ හින්දා මේ hole එකක් තිබ්බත් වටේ ටික ඒ විදිහටම expand වෙනවා කියලා හිතලා කරන්න පුළුවන්. Not even this one, you can write this for the gap like cavity volume එක volume cavity එකක් තියෙනවා නම් it's the same thing you can do. අපි තුමු දැන් you have එකම length එක තියෙන string අය එකක් තියෙනවා කියන්නේ metal එකක් ඔය වගේ gap එකක් හදලා දෙනවා. මේක මෙහෙම හදන්න පුළුවන් ඒ gap එක. ඒ length එක මේ හදන්න පුළුවන් ඒ gap එක. then temperature එක වැඩි කරා if this gap size is same එතකොට ඒක මේ length එක එකම නම් මේ gap එකේ size එක වැඩි වෙලා එන්නේ ඔය තුනේදීම එකම සමානව තමයි වෙනසක් වෙන්නේ ඒකව material වලින් fill වෙලා තිබ්බා කියලා හිතලා you can write the equation මේ gap එකේ size එක අපි තුමු දැන් x කියලා but මේක temperature එක වැඩි කරා නම් x you can write that is the new gap is equals to the x times plus alpha delta t again by the expansion of this. You can apply this for the gaps, hole and cavity anyway. Can gap එකක් වගේ එකක් එන්නේ 1 dimensional. The hole එකක් එන්නේ 2 dimensional. Cavity එකක් එන්නේ 3 dimensional. Same way you can write the equation, right? And another applications I missed here, so I will explain this one also before stop the class. Then another 5 minutes with me. Right at another application, it's important. There's a chime of the pendulum clock, how it changes, right? So this is also directly applied for the chime. That's a pendulum clock pendulum IP is depend on the length of the pendulum. Length temperature venas. So if the length change means that the time also change. So the time make a slowly යනවා සමහරලාට fast time එක fast යනවා. අපි ඒක චුට්ටක් බලමු. You can write it as a application, right? I'm writing the effects of temperature on the time period of a simple pendulum. Time period of simple pendulum clock. Right. In here, second right in the it's a pendulum as a length L at the temperature T1. And this case the time period is T1. T T naught get and at the T temperature T so theta 2 time period is T and then length will increase L dash. It's a temperature increase, theta increase. Yeah. So this time period you can write that T naught equals to 2 pi L over G. And here time period you can write that's 2 pi L dash over G. In this T you can write the T dash you can write the 2 pi. Any expansion coefficient of this material is alpha. So L dash is initial length L1 plus alpha delta theta. Over G. The square root of this. L over G is equals to the T naught here. That's you can write then T naught 1 plus alpha delta theta. एक half power again square root එක ඇතුලේ තියෙන. As the alpha delta theta value is much smaller than 1, then you can write 1 plus alpha delta theta the approximately equals to the 1 plus the half power n 1 plus x to the power n x is small now 1 plus nx කියලා එනකොට මේකත් ඒ විදිහට alpha delta theta කියලා you can write. But you can substitute now. That's a time. New time period is equals to T naught 1 plus alpha delta theta over 2. So change in temperature delta T T naught के मेरे T naught में लगाना. So then it's equals to T naught times alpha delta theta over 2. Fractional change in time. So that's equals to the half alpha delta. So the time pendulum වගේ හදනවා නම් alpha ගොඩාක් අඩු materials තෝර ගන්න ඕනේ. ගොඩක් යාට අපි පාවිච්චි කරන්නේ ඉන්න මේ alpha ගොඩාක් අඩු material තමයි INVAR කියන්නේ. INVAR වගේ materials තමයි use කරන්නේ ඔය pendulum clocks හදන්න. ඒවා තියෙන parts හදන්න. අනිත් ඒවා ගත්තොත් ඒවා time දැන් මේ time එක වෙනස් වෙන ප්‍රමාණය you can measure it. ඔච්චර ප්‍රමාණයකින් වෙනස් වෙනවා. මේක මතක තියාගන්න it's not a time it's affected the time period. මේක time interval එකකට තමයි affect වෙන්නේ. හරි. time එකට නෙමෙයි. Example for 1 second time interval that's a change in time period is in the T naught is 1 second. So this 1 half alpha delta theta. And for 1 minute, you can calculate that 1 minute is 60 seconds. So that change in temperature that is then T naught can go 1 minute, you know, time interval like 1 minute only very good. We get 30 alpha theta. Hi. විතර ගත්තොත් එහෙම so delta theta will be then තප්පර 3000 තියෙන දෙකේ වෙනවා 1000 alpha delta 1D ගත්තොත් දවසක් යනකොට time එක වෙනස් වෙන ප්‍රමාණය තප්පර වලින් ඉව D කියලා කියන්නේ ඒකට 3600 ඒවා 24ක් So then it's equal to 43,200. කියන්නේ අවස් ගානක් යනකොට තමයි ටයිම් එක වෙනස් වෙලා ලොකු ඉෆෙක්ටිව් වෙනසක් එනවා ටයිම් එකේ. කියන්නේ ඔය තප්පරයට වඩා තප්පර දවස් ගානක් යනකොට ටික ස්ලෝ ඩවුන් වෙනවා. ඒ ටෙම්පරේචර් එක අඩු වෙනවා. කියන්නේ මේකෙන් කියලා ටයිම් පීරියඩ් එක වැඩි වෙනවා මේකට අනුව. According to this, that time period increase and the temperature increase. That means that your watch running slowly. When the temperature increase, the watch the time running slowly. Temperature decrease now, this time period is reduced. So then your watch running faster. Is it clear then? I will send some questions to do and then we'll discuss the next week and the linear expansion. The expansion of liquid we need to discuss. See, this thing you keep in mind in the time period, how that temperature change is affected to your time period of the pendulum clock. අපි ගාව තියෙන ඔය අත්තරලොස් වලත් pendulum කියන්නේ ලොකු දිගට නැතුණාට ඒක ඇතුලේ තියෙනවා ඒ වගේ වැනෙන pendulum එකක් ඇතුලේ නිකන් මේ රවුමක් වගේ කැරකෙන එක. බැටරියෙන් දුවන. ඒතර බැටරියෙන් දුවනේ උනත් ඒකේ length එක වෙනස් වුණාම මේක බලපං. So I will stop the class from this point then. So you go through that the questions. I will mark some other questions and send you the group. Okay, monkey na evat karagene next week ke edat api thuru kotasa karamu. Okay, and make a liquid expansion. I will send you the presentation for that liquid expansion also the complete one I will send. Then we can fastly go for the other parts also. Okay, then I will stop the class from this point. If you have any questions, if not, you can leave. Then thank you very much for the participation.